A spherical mirror is exactly what the name implies. It's a section of a sphere. Picture this curve right here as a piece of a three-dimensional sphere. And then these parallel lines are incoming light rays. And you can see at this point right here where this light ray at the top strikes, because of the angle at which it strikes the mirror, it's reflected down. And the same thing happens with this light ray. It's reflected down, and light rays down here at the bottom are reflected up. And just picture that same thing in 3 dimensions. Light rays are reflected all toward this region, which we call the focus. Now, a spherical mirror won't bring light to a perfect focus, and you can prove that mathematically. If you want incoming rays of light to come to a perfect focus, you need a parabolic mirror. So this curve right here is in the shape of a parabola, and this is a cross section. So again, picture this as a 3-dimensional shape. It's like a parabola rotated about its axis. It's what we call a paraboloid in a math class. A paraboloid will concentrate incoming parallel rays of light to a perfect point. And parabolic reflectors like this are really, really useful. They bring these light rays in and concentrate them at a tiny little point there. Antennas are often made this way. The satellite dish antennas or direct TV or something like that, or dish TV, or any kind of large dish that's receiving a signal from a long way away. What happens is incoming light rays or radio waves, which are just a form of light rays, get concentrated. The antenna, the radio antenna in your car, or if you have a radio or a stereo at your house, the antenna, you don't need an antenna like this. The signal that you pick up is relatively close by and relatively strong. The broadcasting tower is relatively close by, presumably in your hometown, and you're listening to the radio, and the signal's strong enough to be picked up with an ordinary antenna. But if you're picking up the signal from a satellite in geosynchronous orbit, it's over 20,000 miles away, and by the time the signal reaches Earth, it's dispersed and is very faint. So what you do with a dish, something like this, you take all of the area that these incoming radio waves are hitting. So they're landing on that much area. So this much signal, this much of the radio wave ends up getting concentrated down to a tiny little point. And that's where you put the antenna. The dish itself is not the antenna. The antenna is just the wire or associated electronics placed at that point, at the focus of the reflector. And that takes the relatively weak signal and concentrates it, makes it a lot easier to detect. The same principle here of a reflection in a parabolic mirror can also be used to make a spotlight. If you were to put a light bulb right here, the light coming out would reflect off the mirror, and the rays would all go out parallel. And so you'd have a nice straight beam of light coming out. Now you'd also have some light rays coming out here that would spread out, and so you often see a wide circle of faint light and a bright spot right in the middle. Car headlights are typically made with parabolic reflectors like this, and a good flashlight or a spotlight in an auditorium would have a parabolic reflector. And a lot of times you can take the bulb here and move it back and forth so it gets a little bit off of the mathematical focus, and that would cause the light beam to spread out some. And so you could adjust the size of the spot that it makes by adjusting the position of the bulb. And if you have a parabolic reflector like this, you never get a perfect spotlight. These light rays never come out perfectly parallel for 2 reasons. One is it's impossible to manufacture something perfectly parabolic. We could get close, but we can never make it perfect. And also the bulb, even if it's a tiny bulb, the filament of the bulb that makes the light is never a perfect geometric point. It has some size, so all of the light being produced is never exactly at the focus. But despite those imperfections, we can still make these and make them pretty well and make a very good spotlight using this principle.